Hello PowerFam. Today's Power topic is inequalities. These are the inequality signs. This sign means is greater than, and this sign means is greater than or equal to. The only difference here is this diagonal line, which means equal to. This sign means is less than, and this sign means is less than or equals to. For further understanding, let us use a number line. X is greater than 5. So we don't know what the number x is, but we do know that it is any number greater than 5. For x is less than 5. Again, we don't know what the value of x here is, but we know that it is any number less than 5. For these two, however, we're going to be looking into more deeply. So x, we don't know what the number x is, but it can be greater than 5 or it could be 5 itself. So we really aren't sure what x could be. We only know that it could be 5 itself or the numbers greater than 5. So x is less than no numbers, so it doesn't have a limit, so it could be any number greater than 5 or it could also be 5 itself. So we're going to start our line from 5 to all from 5 because 5 would be included and all the numbers greater than 5, which would be, so the arrow would be pointing in this direction. And the possible integer values that x could be are 5. 5 will be included because it says that x is greater than or equals to 5. So we aren't sure, so we are just going to write the 5 here. 5, 6, 7. So all these numbers are greater than 5 and it could continue because we don't have a limit yet. So x is less than no number here. For the second one, it's the opposite because it's less than 5. X is less than 5, but it also could be equals to 5. So we are going to include the number 5 here, and the arrow would be pointing this way because it says that x is less than 5, and we already have circle 5 here, which means that x could be 5 or the numbers less than 5, and the possible integers value that x could be are 5, so the 5 would be included, and these all are the numbers which are less than 5. Before we move on to exercises, I would like to thank Miss Azida and Miss Lalitha. Exercise 1. You can see this inequality here. 3 is less than or equals to x. So x is greater than or equal to 3. So the number 3 is included. And x is also less than 9. So number 9 is also in the number line. And now, as you can see here, the number x here has a limit. So now it cannot escape because it is between the number 9 and also the number 3. So let's look in the number line. here are the numbers, and as we saw, the number 3 is included because it says that x is greater than or equal to 3. So we aren't sure, so we are just going to write that 3 is also included, and we are going to use a close interval to represent this. We only use the close interval when the number itself is included in the possible values for the integers of the unknown number. And for simple idea, you can just refer to the sign if it has this diagonal line, if it has a diagonal line like this or like this, it means that we are going to shade the circle here, and this is called the closed interval. And why aren't we shading the circle above the 9? Because the number 9 is not included in the possible integer values for x. So we aren't going to shade the 9. So the possible integer values for x are 3. The 3 would be included because it says that x could be greater than or equal to 3. So 3 would be included, 4 would be included, 5 would be included, 6 would be included, 7 would be included, 8 would be included, and 9 would not be included. So the limit here is from 3 to 8. So the number x, the x could be any number including 3, 2, and including the number 8. So it could be any number including these both, and also in between here. Let's move on to exercise number 2. We have to show this inequality on a number line, and we also have to list the possible integer values for y. Let's look at the number line. So y is greater than 5, but it has no chances to be equal to -5. So -5 would not be included as the possible integer values for y. But -1 would be included because it says here that y is less than and could also be equals to 1. So let's mark our limits here first. So it's from -5 to -1. So -5, we already know that it could not be included, but the numbers greater than -5 would be included. So as we know that we have a limit here, which is -1, but -1 would be included because y is less than or equals to -1. So we aren't sure that y is equals to -1 or is less than -1. So we are just going to write here, we are just going to circle the -1 as well. So the possible integer values for y are -4, -3, -2, and -1. For the next exercise, we need to write in words what these inequalities mean. So always remember that we need to make x the subject. So if 6 is less than x, it means that x is going to be greater than 6. And for this one, we're just going to write in words that x is less than 11. For the next one, we just need to add the equals to, because the only change between this one and this one is that diagonal line, which means equals to. So this is our inequality. 12 is less than or equals to x, and x is less than or equals to 18. So x is greater than or equals to 12. So x could be greater than or it could be 12. And x is less than or it could be also equals to 18. So the possible integers value that x could be would include 12 and the numbers between 12 and 18, and it will also include 18 itself because we aren't sure if x is less than or equals to 18. So it's better that we write the 18 here too. For exercise 4, you need to show this inequality here on the number line. So we know that x is between 4 and 7 because it says that 4 is less than x, so x would be greater than 4, but it would not be 4. And x would not also be 7, it would be less than that. So x could be 5 or 6. And about the intervals here, we aren't going to shade any because x is none of them because they don't have the equals to sign. So we're just going to the x could be 5 or 6, but not 4 or 7 because we don't have the equals to sign. It just states that it is between them here. For exercise 5, we have to use the inequality 12 is less than or equals to x and x is less than 18 to write the smallest integer that x could be. So we know that x could be equals to 12 or greater than 12. Equals to 12 or greater than 12. So the smallest integer that we could provide is 12 itself. And about the largest integer that x could be, it would not be 18 because it says here that x is less than 18. And it does not say that x is less than or equals to 18. It just says that x is less than 18. So it could be any number less than 18. But we need to find the largest integer that x could be. So it would be 17. Just a number short from 18. And a list of the integer values that x could be. So we're just going to state here 12, 13, 14, 15, 16, 7, and until 17. So we're just going to take the smallest integer until the largest integer that this mystery number could be. And here's is a bonus one for you. So Zara and Sophia is looking at the inequality x is greater than 5. So either of both of them might be wrong and both of them might be correct. So it's either of them, that both of them is correct or both of them are wrong. So let's look what Zara says. Zara says that the inequality x is greater than 5 is equals to 2x greater than 10. So first we are going to find out what is x. They haven't given out the answers yet, so we're just going to see the smallest number that x could be. So it could be 6. 6 is greater than 5. So 6 is greater than 5 is equals to 2x it means that x plus x. So we are going to substitute x as 6. So 6 plus 6 is 12. So 2x means 12 is greater than 10. So yes, it is correct. The inequality, so Sophia says that the inequality x is greater than 5 is equals to x minus 2 is greater than 3. So we have to find out the x here. So we already have find it out, and x here is 6. So let's substitute x by 6. So 6 minus 2 is equals to 4. So 4 is greater than 3. So therefore, Sophia is also correct. Thank you very much, and if you haven't yet subscribed to our channel, please do so.